A couple of days ago, I was invited to a medical conference in which the topic of my presentation was how can medical science benefit out of data and artificial intelligence? Now, based upon the discussion with various medical practitioners post the session, I have since revised this presentation to include some additional topics, and I thought it would be a good idea to create a recording of this presentation and make it accessible for others learning. Now, a few key learning which are expected out of this talk. We're going to look at data, which is called the new currency. We are going to specifically look at data from the perspective of how it can be used in medical sciences and respective institutions. Then how can technology in general and data in particular can help in policy making at a hospital level, at a district level, at a city or a provincial level. Next, I'm going to talk about artificial intelligence, machine learning, and how is it different from deep learning. Next, we are going to touch base at generative AI. We're going to look at various use cases because this is the talk of the town these days. And based upon that insight of the use cases, we'll try to sketch out how the future is going to look like. Now, I just want to highlight that since this talk was meant for doctors, which are not tech savvy, I have presented a very simplistic view. In reality, there would be more complexities involved, both from a technical angle as well as from a policy making perspective. And specifically around artificial intelligence, there is a very strong ingredient of responsibility or responsible AI. Again, I'm taking a very simple form. I will touch base this topic, but I'm keeping it for a later day. Now let's take a look at some of the actors which will be part of our story. First are the patients. And along with the patients are their loved ones, their family, their kin. Next, we have got medical practitioners. These could be doctors, nurses, radiologists, and others. We're going to touch base medical institutions as actors. These could be educational institutes, these could be hospitals, lab centers, diagnostic centers, and others. We are going to specifically touch base policymakers, both at a local level like a hospital and at a district or national level. And lastly, the medical companies. These could be startups which are working in medical space or pharmaceutical companies. Now let's start our story with the basic interaction of a patient visiting a doctor in a hospital. The red boundary here denotes a hospital. In this part of the world, this conversation between the patient and doctor rarely get recorded in digital form simply because the softwares are not available and there are very few hospitals within Pakistan where the doctor might have access to an automated system or a medical system where they can record some of the observations. These could be details of the patient, for example, their gender, their age, what are the conditions which are prevalent, what are the medicine which are described. But to highlight that even if there is an application available, these entries are manually going to be performed by the doctor. And this is a big issue in Western world where there are automated systems, but still the doctor or the medical practitioner has to spend a good amount of time making sure that the right data is entered. We're going to come back to this later. Now, over a period of time, this database may turn out to be a complete EMR system, but nonetheless, it's going to grow. Now, once the database has grown, the hospital now brings up the digital policy, and they take aboard a data analyst to uncover what is inside this database record. And so our data analyst comes and starts drilling into the database, and he is able to uncover some information which is known as actionable insights. Insight based upon which the hospital policymakers can perform certain actions. For example, he can uncover the population health trend. Are there any particular seasons in which there are particular diseases which are on the rise? Is there a particular disease or condition which is prevalent in particular part or demographic? He can uncover details about the hospital. For example, how many admissions are being made in the hospital per day, per weeks, over a period of time? What is the utilization of particular rooms? Are there any referrals which are being made? He can uncover details from a financial angle. For example, what is the spending pattern of the people and various other. But most importantly, this analyst may uncover details about the research opportunities amongst the doctors and between the hospitals and other institutions. For example, MIT might be working on an algorithm, but for that, the data sample that they need might be prevalent in our society. And only if this detail is available, this data analyst can feed this such information to the doctors. Now, as the country is going digital, each hospital has its own database. And now at a policy making, at a government level, we also have a national or a provincial data team, which is able to look at holisticity of these records and then come up with some analytics. On a day-to-day basis, this national or provincial team can proactively look at and find out patterns. For example, they might uncover that there is a particular form of fever which is on the rise. But it doesn't stop here. This national and provincial data team would have access to other records from other walks of life as well. For example, they would have access to the pharmaceuticals production rate of a particular medicine which is used for the cure of this particular fever. And combining these two variables, they might come up with something like this. Looking at the pattern of consumption as well as production, they might come up with a certain number in terms of predictive analysis that in given days, this particular medicine would be scarce in the market. And such sort of actionable insight can be fed to the policymakers at a national or a provincial level, could be fed to the bureaucrats or elected personnel who would then take the corrective action. Now, since our data analyst was able to uncover a lot of hidden details in the data or the EMR system, the hospital now introduces the AI engineers to start building programs which help its medical practitioners perform better actions. So this AI engineer of ours comes up and now he has access to the EMR data. Now, of course, this is a very simplistic view in which we have showcased that the AI engineer not only has access to the medical records of the patient, he has access to the lab samples, he has access to the books and publications and scans, all sorts of data is accessible. While in reality, this may not be true. In reality, there is a lens of ethical AI which comes up and only limited personnel have access to limited information. However, this AI engineer of ours will be able to train AI model around a specific medical aspect. Now, everything else that we are going to discuss would fall under this circle of artificial intelligence. So let's begin with the case of machine learning. Now, machine learning is a class of problem in which we are able to solve a particular problem, but by looking at a structured data set. For example, we can identify the risk of heart diseases by looking at the patient medical data, but something which is structured and readable. Let me quote you an example of it. On the left-hand side, we have got CBC. Now, if you have ever got your CBC done, you will notice that in the printed report or the digital report, we not only color code the values which are anomalies, we also specify the range. So the medical practitioner already understands what are the values which should be legitimate. However, the permutation of these numbers are too many. And if there are anomalies, you can think of millions of anomalies. And that's where the machine learning algorithms step in, that they can look at those patterns which are structured, and based upon the insights provided by the medical practitioner and researchers, they can look at these data points, correlate them, and do a predictive analysis of what sort of disease could potentially be. The same is true for ECGs, where a medical expert looks at a certain pattern, he understands that pattern, is able to decode it, and then the machine learning algorithms are able to mimic that experience. Next, let me present you a practical use case using machine learning. Think of a senior citizen who might have some underlying medical conditions. Now, even with today's technology, there are medical grade wearable devices available which record these vitals. The list that you see in front of the screen may not be an exact representation, but vitals like blood pressure, temperature, and others can be recorded. Now, using LTE or Wi-Fi services, these vitals can be synced with an AI engine every minute or periodically. The AI engine would then look at these variables and based upon certain pattern can trigger an alarm. Using that alarm, either an elderly care platform can be put to execution, who is now going to attend the senior citizen, or the kin of that senior citizen can be notified. Now that I believe is a sweet spot in our market because a lot of people would be interested in paying a good amount of money for such services to be made available. This is one such example where machine learning algorithm can be put to execution for the benefit of the society at large. We'll move forward from machine learning and now we're going to take a look at deep learning. Now, deep learning is a subset of machine learning in which we look at unstructured or unlabeled data, and through unsupervised learning, we try to solve the problem, more like reverse engineering. A classical example of that would be solving for skin cancer amongst the patient from scans. Let me explain that a bit more. Now think of these three hands as the scans of three different patients available to the medical researchers, and all three of them were exhibiting some underlying conditions. It is only after some time that the researcher learned that only one of these three exhibited cancer. But looking at those images, when the scans were performed, it was very difficult to identify whether there is a pattern which is going to lead to an anomaly like cancer. Now think of a case where a researcher is trying to solve this problem, but he has thousands or millions of these scans available, and it would be humanly impossible to look for the patterns amongst them. Now, after the fact, we know that which of these patients developed cancer, which one did not, but a researcher have to spend enormous amount of time to decipher what exactly did rise to such an anomaly. And that is a classical example where deep learning can be put to execution. Now, this is taken from a research paper. Osteoarthritis is a practical example of an anomaly or a disease in the knee which cannot be determined until the damage has been done. And so, the researchers tried to solve it in such a way that they looked at two groups of scans from osteoarthritis patients or potential patients. Now, just looking at these two groups, one of them belongs to those patients which develop osteoarthritis, the other which did not. Now, this problem was handed over to deep learning algorithms. And so the remarkable part here is that this algorithm was able to do predictive analysis 3 years ahead of the time with an accuracy rate of 86.2%. And so the question arises, what did the algorithm see that the doctor were unable to? So it turned out that the deep learning algorithm focused on how the distribution of water is in the cartilage. If it was evenly distributed, the deep learning algorithm concluded that there is not going to be any osteoarthritis, versus the one in which there is a pooling of water at the center. We could predict that there is going to be weakening down the road. And so what we learn here is that deep learning is a great tool to do predictive analysis. We'll move forward from here. Now, while we are directly jumping from deep learning to generative AI, I want to highlight that there is a class of algorithms or models which are called foundational models. And they are a subset of deep learning models. Simply put, foundational models are good at solving multiple problems using one of the models. And generative AI is an evolution of foundational models. Now, a classical example of generative AI would be large language model, which are able to understand text, summarize text, or even generate new form of text. However, generative AI is not only limited to large language model. We also have generative AI models around vision, sound, and other forms of data. Let's take a practical use case of it. You might remember this slide from the beginning of this presentation or video. And remember that I highlighted that the doctor or practitioner, even the Western world today, despite the fact that they have access to the IT or software applications, they have to manually record all the observations. That's where the large language model could be a lot helpful. For example, they can hear the audio conversation which is taking place between the patient and the doctor, and then summarize that into a particular format. They can enforce standards like annotation or particular code which are to be applied, or it can even make a recommendation to the doctor. Now, I want to highlight that at present, industry is not mature where the large language model is able to take a decision on behalf of the medical practitioner, but we are moving towards that. Another use case of large language model would be in a scenario like COVID. So think of a black swan event from a medical perspective in which there is a surge of patients and the doctors are just not able to entertain all of that. Well, that's where our deep learning or AI engineer can step in. Based upon the learnings that they have or the data set that they have, they can evolve an AI model or a deep learning or a large language model who is now able to mimic what the doctor is able to suggest. For example, in a scenario like COVID, we can just quickly create a website or a mobile app, whatever channel works best for you, and that online doctor or chatbot is now able to take a lot of queries from patients. So this way, we can alleviate a lot of burden from the medical practitioner and take it with our AI model. Again, the large language model here may not be in a position to prescribe the next steps, but at least it can take away some of the basic discussion from the medical practitioner and make room for that. Another example of generative AI model can be found where we have to build molecular structure for drugs creation. Now, since medical sciences is not my forte, I would just talk about it. You can look at the research paper, but I want to make a note that just 2 days back, Google's DeepMind unveiled AlphaFold 3, and it helps in prediction of protein structure. And these are very complex structures when you have to create new drugs. Now, building on top of these drug samples, another area which we see getting popularity in the medical industry and around AI is to prescribe medicine specific to the person. You see, if a single shirt size does not fit everyone, how is it possible that a given drug would work equally well on all the patients? And so the medical industry is carefully examining the way in which we prescribe the medicine. And there is a very strong notion in the medical sciences that we prescribe medicine which are specific to the people. These are personalized medicine. So looking at their lab test, reports, genetic sequence, and biomarkers, the practitioner or algorithm would be able to prescribe particular form of drug, salts, proteins, which would have tremendous amount of impact on the well-being of the patients. Now, taking this notion of personalized medicine, why not 3D print them? So the underlying idea is that if you can have personalized medicine, you might have the chemical formulation of them. You can visit a chemist or the medical shop, and they are going to 3D print it for you. That's certainly a future that I'm looking forward to. Now, lastly, to conclude all of this, I want to go back to our AI engineer who was building new models. So remember, the hospital took up an initiative and took aboard a data analyst. This was an investment that the hospital took. And the journey then led to artificial intelligence engineers, machine learning algorithms, deep learning models, and finally, we believe that our ML engineers or deep learning engineers are able to create a domain language model. So what's a domain language model? You see, post the foundational models like large language model, the industry is now moving towards a consensus that the future resides with domain language model. These are foundational models or generative AI model, but built around a particular industry. So the models which are built for pharmaceuticals would be different from those built for agriculture industry, would be different from for those in the fintech or telecom. So think in this way that the journey that started by launching of IT applications or going digital, 20 years from now, it will help our ML engineers create new models, which are domain-specific model or domain language model. And once these models are mature, it is going to pay back in a form that is not considered by the policymakers of today. To explain that, once a model is mature, the medical companies, the large medical corporations might come and say, we are interested in your model, name your price, and they might acquire you or buy it. Again, this is a simplistic view because around the medical data, there would be a lot of checks and balances. But another way in which the hospital can make money out of it is by making it available to other third parties as a subscription. So that's where we go full circle. An investment which was made 20 years back might yield a return 20 years later. So that's where I'll stop. I hope you like it. I've tried to keep it as simple as possible while explaining the constructs, giving rise to the ideas of what practical use cases could be out there and how data and AI can help in medical sciences in general or for policy making in particular. Thank you.